Hey guys, I'm continuing straight on from the previous video. So now I'm going to be looking at the area required per meter. So the way we do that is we look at the moment having to be greater than the design moment. So that's in the X direction, and we're going to be doing the same in the Y direction. So we know that the phi value is 0.8. The moment is the area times the lever arm. So the area of steel times by the stress in the steel. So area times the stress. The yield stress of steel is 500 MPa. So that gives us the force times by the lever arm, which we said for a slab which is 0.95 D. So 0.95 times, and we know little d is 199. So we've seen that in previous videos. If I just find it for you, little d over here is 199. So that is going to give us the moment, and this has to be greater than the design moment of 46.8, and we're working in in newtons millimeters, so I need to multiply that by 10 to the power of 6. And if I work this out, we would find that the area of steel would need to be greater than 619 millimeters squared per meter. Just to show you what all these components were, this was phi, this is obviously the area, this is the yield stress of steel, this is 0.95, and this is little d. Okay, which we just rearranged to get the area of steel has to be greater than 619 millimeters squared. Now we need to check that against our minimum steel requirements. Our minimum area requirement was 338 millimeters squared per meter. So this is greater than 338. Okay, which is good. So we're going to be using that value there. We just take the maximum of the two, which is 619. We then can work out the spacing. The spacing is going to be the area of an N12 bar, which is 113 millimeters squared. On top of